5.5 Reflections and Translations Notes. So, a rigid transformation or isometry is a transformation that preserves the shape's size and shape. Thus, a rigid transformation, the two images are congruent. So after you perform a transformation that is rigid, the shapes are still congruent. Okay, the size does not change. So types of rigid transformations are translations or slides, reflections, and rotations. Types of non-rigid transformations are dilations. Transformation notation. The pre-image is the original shape, and we call that, for example, triangle ABC. The image is the resultant, and we call that triangle A prime, B prime, C prime. This first example, we are given triangle DEF, which I need to put on my paper. D, E, and F. So this is triangle DEF. Translate the figure 3 units left and 2 units up. So you're going to start by writing down the original points. So I have points at 3, 3, 5, 0, and 2, negative 2. Then in your picture, you can go ahead and count. So 3 units left. So taking D, 1, 2, 3, and then 2 units up, 1, 2. So this new point is going to be D prime. It's our new point. You have to distinguish between your original shape and your new shape, and that's why we use the primes. And then for E, 3 units left, 1, 2, 3, 1, 2. So this is going to be E prime. And then F, 1, 2, 3, 1, 2. F prime. So this is my new shape. Writing down our new coordinates, D prime is at 0, 5. E prime is at 2, 2. And F prime is at negative 1, 0. So what happened to the coordinates? X, Y, if we look up here, X, 3 became 0, 5 became 2, 2 became negative 1. So all of our X's, if we moved 3 units left, we are subtracting 3 from our X values. 2 units up, so 3 became 5, 0 became 2, negative 2 became 0. So we are taking our Y's and adding 2. Example 2, a translation given by the rule xy into x plus 4, y minus 6 would move a point in what direction? So if I translate this rule into words, if we are adding 4, we would be moving to the right 4. And if we are subtracting 6, we are moving down 6. For 3, if an image is at A, negative 6, 5, that was transformed with the rule xy is x minus 1, y plus 2, what is the pre-image? So what is the original image that we started with? To move backwards, we have to find the opposite of the rule. Okay, so here in this example, we are given our image. We are given the final result. You have to find the original point that we started with. Since we are finding the original point that we started with, we are taking the opposite of the rule. So it would really be, we would be taking the pre-image and going right 1 and down 2. So A prime, which is at negative 6, 5, would become A. Right 1 would be a negative 5. Down 2 would be 3. Okay, so normally we start with A, and you follow the rule exactly, which would give you the negative 6, 5. Here we are starting with our image, our A prime, and we are going and trying to find the original image, or the original point. For number 4, give the rule for the following translation. Here, we're just trying to find, for translations, you can count on the graph. So if I choose Z right here, we are going, let's do right or left 1. So we are moving to the left 1. And then we are moving 1, 2, 3, up 3. You can double check that with all of your points. So for X, left 1, 1, 2, 3 up. Good. W, left 1, 1, 2, 3. Perfect. So if I translate this into a rule, X, Y becomes X. If we are going left 1, we are subtracting 1. And if we are going up 3, we are adding 3. That would be our rule for this graph. Okay, so moving on to the back for reflections. We are starting here on your paper. I have the points written up here, but D is at 2, 2. E is at 4, negative 1. And F is at 1, negative 3. So reflections flips the shape over a given line. The shape will have a new orientation, and the line of reflection is the perpendicular bisector to the segment that contains a point and its image. All right. So A, reflect triangle DEF over the axis. What happened to the coordinates? So let me go ahead and graph triangle DEF. D, E, there's DEF. So on my paper, and I would like everybody to do the same, you should always write out your original coordinates and then your new coordinates. So D was at 2, 2, E at 4, negative 1, and F at 1, negative 3. Let's see. Okay, so I am going to be reflecting this shape over the x-axis. So I will be reflecting it over the x-axis. When I do this reflection, one way you can do it without following a rule is by counting. So for example, D right here, you are counting towards the x-axis. So 1, 2, once you go and hit your line of reflection, go 2 in the opposite direction. 1, 2. So here is D prime. So then D prime would be at positive 2, negative 2. Positive 2, negative 2. For E, now we're going towards our line of reflection, so I need to go up towards the x-axis. 1, and then I hit my line of reflection, so I'm going 1 in the opposite direction. So E prime. E prime is at 4, positive 1. And then for F, go towards your line of reflection, 1, 2, 3. So I'm going 3 in the opposite direction, 1, 2, 3. So here is F prime. So my new shape is here in red. So F prime is at 1, positive 3. So if we look and compare our points here, 2 stays the same, and then our y value 2 became negative 2. 4, 4, and then negative 1, positive 1. 1, 1, negative 3, positive 3. So here it looks like our x's stay the same, but our y value changes sign. Okay, now this is where things are going to get messy. So if you want to pull out colored pencils for these notes, I probably would. So I'm going to change and use, well, let's go ahead and write down our original points. So D is at 2, 2. E is at 4, negative 1. F is at 1, negative 3. I am going to use, let's see, another bright color would be green. So now I am reflecting over the y-axis. Okay, so now I'm taking my original point D and counting towards my line of reflection. So 1, 2, going 2 in the same direction. 1, 2. So that means D double prime is right here. That point would be D double prime becomes negative 2, positive 2. And yes, I would like to see the original point with the new point on your paper. E 1, 2, 3, 4 until I hit my y-axis. So then continue to go 4. 1, 2, 3, 4. So E double prime. That means E double prime is at negative 4, negative 1. And then F1, so right here, F double prime would be at negative 1, negative 3. Okay, so here is our new shape. So when I look at this, what changes in our rule? So 2 becomes negative 2, 2, 2. 4 becomes negative 1, but then our y values stay the same. 1 becomes negative 1, and then our y values stay the same. So here our x's are changing. Our y values are staying the same. Okay, what happens if it is not one of the axes? If it is not one of the axes, you're still going to draw. So my original point DEF, let me plot that really quick. For negative 1. Right there, there's DEF. We are going to be reflecting across the line y equals x. So again, D is at 2, 2. E is at 4, negative 1. F is at 1, negative 3. I'm going to use red again. So now I'm reflecting across the line y equals x. That is a straight line with a slope of 1 and a y-intercept of 0. So your line looks like this. There we go. So here, reflecting across this line, D stays the same, so this is also D prime. If a point is sitting on the line of reflection, it does not move. So D prime stays at 2, 2. Then for E, if I count towards it, 1, 2, 3, 1, 2, 3. Right up here, it's harder to count on these ones. So E prime becomes -1, 4. It's right here, E prime. And then F, kind of count that one too, right here, F prime. So then F prime is at -3, 1. So if we look here when I'm comparing my points, it looks like our Y's and our X's are changing locations. Okay, so they're being flip-flopped throughout our picture. So XY becomes YX. Okay, what about the line Y is equal to -X? So again, I'm going to draw my points. D 2, 2, E 4, -1, F is at 1, -3. I'm going to do this one in green to show you the difference. -X, it looks like this. There's that line. And then again, I'm going to try to count towards it. So here is D double prime. So D double prime, -2, -2. E oh, we're right here. These ones are harder to count. So E double prime becomes 1, -4. And then for F we go right here. There's F double prime. F double prime goes to 1, 2, 3, +3, -1. So here is our new triangle. So when I look at that, comparing my points, you can see looking here at 4, -1, our Y values change. So they flip-flop and both signs change. So it becomes -Y, -X. So those are some rules for flipping over different lines. So you can either count, but for the line Y equals X and Y equals -X, it's definitely easier to use your points than to count for the lines. So example 3, how is triangle HLQ transformed to triangle H prime L prime Q prime? Give a description and a rule. It is looking right here, L stays the same. If I count, it looks like it's being reflected. It looks like it is a mirror image across this line right here. It is a mirror image. So it looks like it is reflected across. Vertical lines are X equals, and it's X equals 1, 2, 3. So -3 there. Example 4, reflect triangle ABC over the line y equals 3. So let me graph this really quick. Take a second and graph these points on your paper. 1, 2, 3, 1, 2. So we were reflecting across the line y equals 3. Y equals 3. If x is a vertical line, y equals is a horizontal line. So go to 3 on your y-axis. This is our line of reflection. And then let's go ahead and do the reflection. So these ones just count. 1, so C prime becomes right here. 1, 2, 1, 2. B prime, 1. Here is A prime. So our new triangle, and then let's write down our points. So A is at 3, 2. A prime is now at 1, 2, 3, 1, 2, 3, 4. 3, 4. B is at 1, 5. B prime becomes 1, 1. C is at -2, 4. C prime is at -2, 2. And there you are. So a lot of reflecting is counting towards your line of reflection, and then drawing your new shape from there.